Hello everyone, welcome back for another video. Today we'll be looking again on staircase works, taking off staircase works. We have already done a video about staircase, but still a lot of you have been asking me to do a next question that covers staircase work, and so I went and looked for a next question paper and I saw a question and I did it for you, and here it is. So if you're new to this channel, this is a channel where we help students prepare for their exams in the simplest way possible. And also for those who have graduated and you want to remember a concept, always come back to our channel. We will remind you and also help you polish up on your quantity surveying skills. So welcome to this channel. Feel free to subscribe and also to click on the notification bell so that whenever we post new videos, you can be notified. Nowadays, we post a video a day. Each day we have a new video for you. You have to be so good in quantity surveying by the time that you're watching all our videos. So welcome back. Thank you for all your compliments, for all your comments, for your questions. We are working on them and we are doing our very best to prepare you for exams and also to make you the best that you can be. So today we will kick off with starting to do taking off staircase work. You can see the question was using the drawing number 2, which is there down, shows the drawing number 2 shows the plan, section, details of a staircase. Take off all quantities for the staircase using SMM. Yes, the documents that we use is SMM. There are those who are asking, what are we using to take off? We are using the standard methods of measurements, and for all the civil works we are using the CESMM. So we have the plans. We'll be highlighting for you. Sometimes I'll use the pointer because a few said that whenever I use my paints, sometimes it is not visible, so I'll use my pointer where necessary, and where necessary I'll highlight or draw. So we have the first floor plan here. The first floor plan, we can see that the thickness of the wall here is 215. The staircase has a landing here of 1200. Then we have 1800 for all the stairs, then 1200 landing, then 215 for the wall. For the width, we have 215 for the wall, the thickness of the wall. Then we have 1200 up to the where we have this wall. Then the thickness of this wall is 215. Then we have 1200, then 215. This section is section X. Section X is this section XX here. So in section X, we can see that at the landing, the thickness of the concrete is 175. Then we have this detail here. This detail is called B, and when it is made bigger, we can see we have 25 millimeters terrazzo on the staircase. Then we have 40 times 20 millimeters carboruda insert, or this one is usually on the staircase so that to prevent slipping. This one you have 12 millimeters thick plaster, and it's painted at the base of the staircase at the soffits. Then here we have 12 millimeters main bars at 250 center to center. They are lying on the soffit on the staircase this way. Then you have 10 millimeters diameter MS distribution bars, 2 number at every step. So 10 millimeters is maybe it's D10. Yes, D10 MS distribution bars. You know the bars sometimes use Y10 or D10. We have 2 bars at every step going that way. Then we have concrete, which is ratio 1:2:4. Remember, we need all these details when you're taking off. You need to study your drawing so that you can know what you're expected to take off, because anything that has been shown on the drawings, you should be able to take it off. Alright, then we have 25 by 25 by 1100 millimeters MS standards. Remember, standards are these ones that are vertical. Then we have the bottom rail, which is 50 by 15 MS bottom rail. Alright, here we did not finish studying. The height of the standard is 960. Then 50 by 20 MS handrail on top here. Then we have 20 by 20 by 600 ms balusters. Balusters are these ones that they are not coming to the concrete, they are hanging between the bottom rail and the top rail. I hope you can see that. So if we have to count the standards, this is the standard here. 1, we have standard 2, we have a standard 3, standard 4, standard 5. You see? So these ones that do not go to the concrete, they are called balusters. Then we have the MS standard. Standard, you can see it's going up to the floor. Alright, the trends are 225 millimeters and the rises are 175 millimeters. And then we are shown that the staircase is going this way. So here it's down, then you come up, here there's a landing, then you go up. Here, when you want to go down, they're saying that you go this way down. Right, so I hope you can be able to see. So we will start off, we shall kick off taking off the staircase works. When you are taking off staircase work, we'll start with the concrete work. When you are doing concrete work, we will do first the formwork. We shall calculate all the formwork that we shall require for the staircase. Then we shall go to concreting. How much concrete do we require? These ones where it's sloping, at the landing, it slopes again, landing. Alright, then we have the reinforcement. We shall calculate the reinforcement. Then after we are done with that, we shall go to the balustrades. For the balustrades, we shall take off the rails, the balustrades, the standards, the MS holes that the standards will go into the floor. Then we have the milled steel plates. Then we go to the finishes. We have seen the terrazzo, the non-slip insert, the plaster at the bottom of the soffits. Then we have the painting. So all this we are going to take off. Alright, I'll start with formwork, and we shall start with formwork for the landing. In formwork for the landing, we shall calculate the length and the this one is the length, then this one is the width of the formwork. Remember, we are talking about formwork is that that's either timber or even steel that will hold the concrete in place before it dries. So when we say that we are calculating formwork, the area for the formwork, we shall take the width. See, at the landing, we have this step that is up to here. You know, the steps are up to here. As in, if you look at these steps, the last step is here. But if you look at the base of the step comes up to here. So for the length, formwork will be like this. Follow with me. It will be a rectangle. If you see here, the landing from the top is this length, which is 1200. But the landing from below, it is from here to here. So it means that if you draw a vertical line over here, then you deduct this length of one trend. You know, this is the length of one trend. You remain with this length of this landing. It's a width. Then remember, when you are doing formwork for the landing, we will not include the wall here because the wall will hold its own concrete. So we'll only do formwork from here inside the wall up to here. So that's why we are taking 1200, which is this width. Then we deduct 225. 225 is the width, the length of this one trend, which is equal to here. All right, 1200 we deduct 225, we shall get 925. So we go to the first flight. At the first flight, this is called the first flight, then this one is called the second flight. At the first flight, we need to calculate the length of this soffit. You see this part that is lying like this? This is the soffit. Actually, this staircase is different from the other one. Kindly go noting the differences. So we need to find the length of this soffit here. How do we calculate the length of this soffit? Here, I'll use a pen. This one, we usually extend this length here. You draw a straight line. Then from here, also draw a straight line. And you'll see that they form a right-angled triangle. To calculate this length here, this length of the soffit, it is hypotenuse to this triangle. How do we find the length, the height of this triangle? You will just come and extend this and find that this triangle, the top of the triangle comes from this step here. So we shall continue extending these lines. One, we extend them. Kindly, this one I'll take you slowly so that you can be able to get the concept. Extend them. We want to know how many are the height of that triangle. If we are able to know how many risers make up the height of that triangle, we can be able to calculate the height of that triangle. So we continue extending. We extend up to there. So we'll just calculate 1 riser, 2 risers, 3, 4, 5, 6. So there are 6 risers. Of what height? 175. You see, risers here is 175 millimeters. So 175 millimeters, 6 risers. So the height of that triangle is 1050. We go to the base of that triangle. How do we know what is the length of the base of this triangle? This triangle, if you extend this line, here, you'll find that it will end at this one trend. So if we descend these trends, they will help us to know the length of the base of that triangle. So we extend these ones. We extend them. So, and this one will form this one. So, what is the base of that triangle? It's made up of 1, 2, 3, 4, 5, 6, 7. 7 trends will make up the base of that triangle. Let's count again. We have 1, 2, 3, 4, 5, 6, 7. So the base of that triangle will be 225. The number of trends we multiply by the length of the trends we multiply by 7. All right. If we do that calculation, we shall get 225 times 7. We shall get 1575. All right. Then we shall take 1575 squared, and we get 2,486,625. Then, all right, 1575 squared is 2486.25. Then we take 1050 squared, we get 110.2500. When we add the two square roots to get the hypotenuse, we shall get 1892.91. We go to the second flight. The second flight, I will use the pen. We shall draw a triangle also. We draw a straight line to form the triangle. Then from here, we draw a straight line. So we shall form a right angle triangle. We want to find the length of this soffit. So we shall start with finding the base. So we shall extend these lines to know how many trends make up the base, so that you can be able to take the length of each trend, then we multiply by the number of trends. So we extend, use straight lines. Mine are not very straight. All right, so we count how many trends make up the base. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 225 times 9 to calculate the number of bases. The length of the bases is 2025. We go to the height. How many risers makes up the height of this triangle? You see, it starts from this one. So we extend this one. We extend. We extend. Use straight lines. Mine are not so straight. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 risers. So one riser is 175, 9 risers. So we shall get a total of 1575. Hypotenuse, we get it by a squared plus b squared square root. So 2025 squared plus 1575 squared square root, we shall get this one. All right, 2565.39 for the soffits. Now we want to know the area for the formwork for the sloping soffits. So we shall take the first one, which is 18.92. 1892.91. That is in millimeters. So in meters it shall be 1.89. Then the width of the soffit, it's from here to here. We shall get 1200. Remember, we don't do formwork where the wall supports the concrete. So we do where there are no walls. So the width of the sloping soffit is 1.2. Then for the second flight, we shall take the length of the soffit. It's 2.57. The width of the soffit is 1.2. We go to the landing. How do we calculate the formwork for the landing? We shall take the width of the landing, which already we had calculated, which was 0.95. Then we multiply by the length of the landing. The length of the landing, we shall take 1200 here plus 1200. We add this to 15 wall, which is at the center. Then we get 2615. So the area for the landing, we shall take 2.62 for the length, and the width of the landing is 0.95. Then we shall go to sawn cypress formwork to the edges of the landing. Okay. Despite the fact that we are not using formwork where there are walls below, we shall use it at the kando, at the sides. For example, the step is up to here. You see, it's up to here below. But when we are doing the formwork, yes, when we are doing the formwork, we shall place formwork this way at the side up to the end of the wall. At the side. Then at the length, we shall start from here up to here. So what is the length? For the width, we shall start with from, so we shall measure from here, let me show you, from here up to here, it's 975 as we got. You add to 15 for the wall, you get 11.90 or 1190. So it shall be 1.19. Then we have some formwork for this wall that we have here, so that it doesn't pour down. We shall do formwork for here 0.22. Then we shall do formwork for all this side. We shall get 30, 50, the total of this one. So it shall be 3.05. You may ask yourself, why are we doing for both sides? In this diagram, we have assumed that we are only doing concrete where the staircase is hanging, where the bottom, you know, in a staircase, one side is supported by the wall, the other side is floating. It's not supported by the wall. So where it's supported by the wall, one side, you see the section is done here. So if it's done here, and you can see these balustrades here, it shows that this is the side in a staircase having this width. We are taking the balustrades are here. So if they are here, this side of the staircase is lying on the wall of the house. It's adjacent to other rooms, but this side it's open. So we are only doing formwork for the open side. This one, we have the wall that is continuous. It extends to the other rooms. So we are doing formwork for one side of the landing. The other one, we assume that's supported by the wall, because in most buildings, we first construct the walls for this one and the other side, then we come do the staircase. All right. I press formwork to the edges of trigger, edges of steps, extreme width 300 millimeters wide, cut into profiles of risers and goings. You know, so that you can make these steps, we have to do formwork, which runs from here up to here. We do formwork that way. So those ones are the ones that no, those ones are these ones, the edges of the risers. These ones that run this way, they are called the ones at the edges of the risers. So let's first count those ones. We shall count the number of risers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiplied by 2, 18. 18. What is the length of that formwork? It's the length of the flight, the width of the flight. The length of the formwork is the width of the flight, and the width of the flight is 1200. So 18 times 1.2. These ones are the edges of the trigger. They are these ones that are here and here. The edges of this flights are called the edges of the trigger. And this formwork, it's taken as the hypotenuse from here to here. We know that. Then from here to here, the hypotenuse. All right. So we had got the hypotenuse for the first flight was 1.71, and for the second flight is 2.57. Now we are done with calculating, taking off the formwork. Now we go to concrete. We shall calculate the concrete, that reinforced concrete ratio 1:2:4 in 50 millimeters thick slab. Okay, in this landing, we shall start with concrete in the landing. You see, it's 175 millimeters. So in the landing, we shall calculate the area of the concrete, which is here 175 millimeters. So we shall place 175 millimeters in the description column. Then we shall measure the length and the width. The length of the landing, the concrete will be from end to end. So you'll just add all these dimensions. You get 3.05. And for the width of the staircase, you can see from the section, it starts from concrete at the landing. It starts from here up to the center of the wall. So if it starts from here to the center of the wall, what is the length from here to here? Okay, if from here to here it's 1200, we deduct 225, we remain with 975. 975 is up to the internal wall. So and it's going halfway. 215 divided by 2, we shall get 107.5. So we shall take 975 plus 107.5. We shall get 1082.5. So the concrete at the landing, its dimension shall be 3.05 for the length. Then for the width, it shall be 1.08. Reinforced concrete ratio 1:2:4 in 150 millimeters thick slab. Concrete in the flight. Concrete in the flight. So it's reinforced concrete ratio 1:2:4 in staircase. What is the volume of that concrete in the flight? We shall take first of all the hypotenuse here, which was 1.71. Then we take the width of the landing where the concrete is. All right. So remember, when you are doing concreting, this side and this side, it will go into the wall halfway for support. So concrete, despite the fact that the width of the flight is 1200, it will go halfway into the wall. Halfway into the wall, we have said the 215 divided by 2 is 107.5. Then we have 1200 for the landing. We add 107.5. We shall get 1307.5. So the width of the concrete at the landing shall be 1.31. Right. Then we shall go to the thickness of the concrete in the flight. The thickness, if you note here, we have, I will do it with a pen. In a staircase, this flight is made up of a rectangle down here, a rectangle. This one is a rectangle. Then these ones are triangles. you take the volume of this rectangle, then you take the volumes of this triangle, you'll get the total volume of the flight. So we'll start with this rectangle. For this rectangle, we are told that from here to here is 175. So the width of that rectangle is 0.175. So 2 decimal places, 0.18. The length of that rectangle from down to up is this length that we calculated here, which is for the first flight is 1.71. Then 1.71. Then the width of the flight is 1.31. Then the depth of the flight for the rectangle is 0.18. So it's here. So for the first flight, this part of the rectangle, we shall take the length times the width times the depth. The depth is this one here. All right. And we say the concrete starts halfway from the wall. So we shall take the flight is 1.71. We multiply by the width of the flight is 1.31. Then we multiply by the thickness of this concrete, 0.18. We go to the second flight here. We shall take the length of this flight, 2.757. We multiply by the width of the landing, which is 1.31. Then we multiply by the depth, 0.18. Now we are remaining with the volume of concrete in the triangles. Remember, to find the area of a triangle, to get the base area, we multiply by the length of this landing. All right, so it shall be a half, which is 0.5. Base of that triangle, we shall take it, the base of this trend. Trend is 0.225. So to 2 decimal places, 0.23. Then we take the height of the triangle, which is the height of the riser, which is 0.175. So it shall be 0.18. How many steps do we have? We shall calculate them from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 risers. So if we get all this total volume, we shall get the total volume of reinforced concrete. Ratio 1:2:4 in staircase, in the flights. We'll go now to reinforcement. Reinforcement, we shall start with reinforcement at the landing. Every time we are starting with landing, then we go to flights. At the landing, we are told we shall start with knowing what is the length of the landing. The length of the landing, we said it's 30, 45, where you take, you add all these dimensions here. Then, you know that reinforcements, how would we do them? We take, let me just sketch for you how reinforcements are. Those bars, we fold them like this. So we have a bend, then a straight line, then we have a bend. So this length will be the length of the landing. Then we shall make bends here. The bend, we shall use 150. The length of this bend, let it be 150 millimeters. So if we want to find the total length of this bar that we used here on the landing, we shall take 30/45, the length of the landing, plus 150. We get 33/45. Then we want to know how many bars did we use. Here we have bars coming this way. So how many bars did we do? Let me sketch. There are bars that will be coming this way, this way. So how many bars? We want to calculate the number. To calculate the number of bars, we shall use this width here. The concrete is going up to here. Okay, let's use here. I think it's easier to see from here. It starts from here. So from here up to here. What is this length? First of all, the width. We said it's, we shall take the total here, it's 1200. 1200 we deduct to 25, we get 975. Then we deduct half of 215. So the total from here up to here will be 1082.5. 1082.5. Then we shall deduct concrete cover on each end, because between the bar and the concrete, the bar and the edge, we need to cover using concrete. Here we usually leave a space of 15 so that you cannot be seeing the bars from outside. They should be covered by concrete with a thickness of 15. So we shall take the width, which is 1082.5. We deduct 30, we divide by 250. Why are we dividing by 250? It's because those bars have a spacing of 250 from bar to bar, then plus 1, because if we start from here, how we calculate the number of things, you take the spacing, divide the total width, divide by spacing plus 1. So we shall take 1082.5. I'm calculating it. 1082.5 minus 30 divided by 250 plus 1, you get 5.21, say 6 numbers. Now we want to know how many bars we shall have on the length of the landing, and they will be like this. They will be running like this. So we want to know the length of these bars and how many will they be. First of all, the length of these bars will be 1200. This one, you see, they'll be up to here. So 1200 we deduct 225 for here, so that we can get this length. Then we add half the wall up to here. So from here to here, and we shall have bends. And remember, we said that reinforcement bars are like this. So this one is the width of the landing that is remaining after deducting 225 plus half the wall. Then we have a bend here at the end and a bend at the end. The bends will be 150. Length 150 times 2, 300. So we shall take 1082.5 plus 300, we get 1382.5. How many bars will there be? We shall take this length from here up to here. Then we deduct the covers. We should leave 15 millimeters cover on both sides. So 2 times 15. Then we divide by 250 spacing. We add 1. So we shall get 12.06. So we shall say 13 numbers for the first flight. On the first flight, we shall ask ourselves how many bars will be running this way. How many bars and what is the length of those bars? So remember that they will be running like this. Sorry, they'll be straight, not like mine. Alright, so the length will be equal to the hypotenuse of this flight. Then the hypotenuse, then we shall add the bends, 300 on each side. Then after getting this, we shall calculate what is the number of those bars. The number of bars, we shall take the width of the landing, the width of the flight, which is 1200 plus 215 divided by 2, 1308. We deduct the cover, concrete cover, we divide by 250, then we add 1. We get 6.112. So 6 bars or 7 bars. Alright, we shall say 6. So we shall go to the second flight. We ask ourselves how many bars will be running this way. So they'll be running this way. And what will be their length? Okay, so to get their length, we shall take the hypotenuse of the flight, then we add the bends. Each side has 300, so the total length will be 3165.39. So how many bars will we have? We shall take the width. We shall take the width of from here, half the wall up to here, 1308. 1308, we deduct the cover. we divide by the spacing of the bars plus 1. We get 6.112. Say 7 number. Go to now recording it in the, we shall book it. Booking it is recording it in the takeoff sheet. Supply the following steel reinforcement bars to BS 4449, including beds, tying wires, distance blocks, laps, all necessary. So for 12 millimeters diameter bar, we shall compile all of them. So we shall start with the landing. We shall have six bars at the landing, whose length is 3.35. You remember now at the landing, where we have the landing, these bars will be going like this. There will be 6 and their length shall be 3.35. Then we shall have 13 bars going like this at the landing. Then at the flight, this way, we shall have 6 bars going like this. Then we shall, whose length is 2.49. Then we shall have 7 bars on the second flight going like that. 7 bars measuring 3.16. Now at the flight, we need these bars going like this. These ones we have been told they are 10 millimeters distribution bars, 2 numbers at every steps. How many steps do we have? 16. So what will be the length of those bars? The length of those bars shall be, we have taken the width of the landing, then we add the beds, we get 1.58. Now to get the number of the bars, we usually calculate them in kilograms. When we are giving them to the BQ, we shall multiply by 0.616 kilogram per meter cubed for the 10 millimeters to get their weight, and for the 12 millimeters bar, we can multiply by their density to get the mass for the 12 millimeters bar. We go to balustrades. The balustrades, we said they are these ones, balustrades. We shall start with the handrail. For the handrail is this one, or the stop here. Then we shall say 50 by 150 handrail. The handrail is 50 by 20 ms handrail. We shall measure them. How many handrails we will require? We shall require this one. We shall take the hypotenuse, which is 1.89. Then we add this one, which is the hypotenuse for the second flight, 2.67. Then we shall add a balustrade for here. You see, 0.22. We shall require some handrail there. Then after the flight, when we go up, up here, we usually require some handrail here. We shall place some handrail, which is 1.2. So for the handrail, we shall prepare and apply 3 coats of clear varnish on the same measurements. Then 50 times 20 millimeters intermediate MS rail. That one also measures the same as handrail. That one is this bottom rail. Bottom rail measures the same measurements as handrail. Then at the same time, you prime and apply 3 coats of gloss on metal surfaces. So for the handrails and the bottom rails, we shall apply gloss paints for all those. We shall now take off the standards. We shall start with counting the number of standards. Remember, whenever you're doing takeoff, you should use the drinks that you're given. So we shall use our drinks. We are given 1, 2, 3, 4, 5, 6. Those ones are the ones that you are given. But you can make an assumption that in the first floor, after we are done with the landing, for example, if you are going down, here, before you start going down, there shall be a handrail and there shall be a standard. So we assume here there is a standard, and this one here is the one which is here. So we have assumed 1 and we have added it. This one is according to what you want. You can just take off what you're given, or you can add 1. So for my case, I have added 1 because this one, it has to be there. We have to have some railing here. So there are 7 standards. We are told there are 25 millimeters 25 we have got it from here on the drawing. Made steel standard, which is 1100 millimeters long. It is here in the description. Welded to a MS plate at top and fish galled grooves in the concrete at bottom. You know the standard is going into the concrete. Then we need to cut holes of 2.5 millimeters diameter, because you know it's 25 millimeters diameter, because they are 25 millimeters. Metal standards, 75 millimeters deep in the concrete and make the work good. Okay, we go to balusters now. The balusters, we shall just count the ones we are given, because we are not given the spacing. If we were given the spacing, we would take this length, we divide by spacing, then we take this length, we divide by spacing, then we come subtracting the standards here at the corners. But now we have not been given the spacing, so we'll just count the ones we can see. We have 1, 2, 3, 4, 5, 6 on the first flight. On the second flight, we have 1, 2, 3, 4, 5, 6. Then we can do an assumption for the first floor landing. We say here we have 3 balusters. Say 3, right? Or you can just take. All right. Then we go to hollow section milled steel balustrades, 600 millimeters long, welded to a MS plate at the top and to the intermediate rail at the bottom. So we shall go to the balusters. Balusters, we shall write them here. So the total we have got is 15. We describe them here. This is the description. Then we come to MS plates. MS plate, we have the equal to the number of standards, because MS plates are found at the bottom of the standards. So we have 7, just like the standards. Then size, they are 6 millimeters by 30 by 150 MS plates. Painting the balusters and the standards. To paint, we need to, the baluster is like this, the cross section is the one that we are taking. For the baluster is 20 millimeters, 20, 20, 20. So the perimeter is 80. All right. If it's 80, then we shall multiply by the number of balusters. Okay. This one, if it's 80, it shall be 0.8. Then we multiply by the number of balusters. Then we go to the standards. The standard, they are 25, 25, 25, 25. So the perimeter is 100. So the cross-check section is 1 meter. Then we shall multiply by the number of standards, which is 7. We go to finishes. 25 millimeters thick polish on landing. What is the width of the landing? The width of the landing, it's from here up to here, up to where the internal wall is. So it's 2.62. Then the length, this one is the width of the landing, 1.2, from here up to here. Then for the length, we shall take from the internal wall to the internal wall, 1200 plus 215 plus 1200. We shall get 2.62. All right. Then we say finishes ditto, but to trend, to 50 millimeters wide. So finishes for the trends, we shall take how many steps do we have? We have 16. Then this length, it's how many? 1.2. 1.2. 1.2 meters. We shall go to 20 millimeters thick polished to terrazzo skirting. The skirting we usually place it here, here, and here. Sorry, here, this wall. So for the length, it's 2.62. For the width is 1.2. You multiply by 2 sides. Then we go to plaster for the soffits of the landing. So the plaster landing, it's here, only this one. So we shall take 1200, we deduct 225, we get 0.98. Then the length is 2.62. And also for the same area, you prepare and apply 3/4 of emulsion plate. We're going to plaster at the soffit of the staircase. We shall take the hypotenuse of the first flight times the width of the flight. The width of the flight, we shall not include the wall because we only do plaster to the area that is not under the wall. The area that if you stand under the staircase, you can be able to touch. So for the second flight, it's the hypotenuse of the flight times the width of the flight. Right, and also prepare and apply as above described, the plaster. Then we shall go to the plaster at this trigger. The plaster here at this trigger, we shall measure in terms of linear meters. We shall take the hypotenuse of the first flight, the hypotenuse of the second flight. Then we shall go to extra over polished terrazzo for non-slip insert. How many non-slip inserts do we have? They are equal to the number of steps, and the length is equal to the width of the flight. So we have come to the end of our video today. I have been doing this quite late in the night because I have to make content for you guys. So I'm sorry if I was a bit slow, but if you have any question, kindly write it in the comment section. We are going to answer them. We are doing our best. Actually, we have been working the whole day, but we had to do something for you tonight so that you can have something to study about. So we are doing our best to do videos for you. So keep subscribing, keep liking our videos, and if we get the necessary support, we shall be able to continue making videos for you. So thanks for watching and have a nice time. Thank you.